Assalamualaikum and welcome to my YouTube channel. So in this video we will gonna analyze a frame by using Etabs 2021. Before starting my video, I request you to subscribe my channel and like this video and share it. We will be solving a frame which will be a bit simple, but there are many new things in this analysis, and this video would be very helpful for you in the upcoming video lectures which will be regarding the analysis of a complete building. So I will be sticking with the default ones settings, and I will also go with default here, and I have three windows opened. First of all, this will be our a frame. It looks bit simpler, but there will be many new things that you will be learning in this video. So stay tuned to this video and watch it complete. So I have units in SI. So first of all, I will be changing my units to SI, and here I have changed my units to SI. Now looking at the structure, we decided our grid line. So I will be having one grid line here and two grid lines in X direction, and one, two, three, and three grid lines in the Z direction. So I will go to edit and edit stories and grid system, and here first of all I came here, and how many stories does I need? I need 1, 2 and 3. So I will be deleting this story. I will be deleting this story as well, and now I will be adjusting the height. So what will be our height? So it is 0, 4 meters and 6 and 2 meters, 0, 4 and 2. So it will be having height of 0 to sorry it will be having height of 6, it will be having height of 4 meters, and base will be having of 0, it will be also on 0. So I have modified my grid system. Now going towards this, in the y direction I will be having only one line, it will be enough, and y spacing is equal to 0. And in the x direction I would be having two grid lines, and if I see the spacing between them is 3 meters, so we'll write 3 meters here, and I will be pressing OK. So I will be changing my elevation view to x and z axis, applying it, and OK. So you can see that I have these type of grids prepared now. So if you see, I have 4 meters upward, then to 6 meters, and now I will be drawing the frame. So I will go to draw menu here, and will be drawing, select this and drawing frame. So first let me change my story height, it will be 2 meter here, and here it will be 2 meter. Okay, and okay, now it's okay. Now I will simply go to draw menu and will start my here to 4 meter, and then I have an inclined frame which consists of 4 meter, and then I have a vertical frame member. like this. Okay, so I have drawn my frame. Now I will be assigning restraints. So if you see, we have a roller support at one end and fixed support at the other end. So will be clicking here and will go to assigned and joint and restraint, and will be applying roller support here and apply fixed support here. Assign joint restraints fixed support, and now it's applied. Press OK. Now the main thing, which is very important thing, is the application of load, and here we will learn many new things which will be very helpful in our upcoming videos. So if you see that we have an inclined load UDL applying at this frame member. So what we usually do in our manual analysis is that we convert this UDL into point load, then convert that point load into its rectangular components. Like this, you can see from a frame here. I have almost a frame here, so you can see that we have converted this into point load, and then we have resolved into its rectangular components, but it takes very much time. So since we have to do in the analysis of a building, we have many frames, we have many members which are inclined, and we have to apply inclined loads like wind loads. So it will take our much time in resolving these components and then applying again and again. So we will be using local axis term here. If I go here now, I will be go to options button, and I have a view problem, so I will go to task manager. First of all, sorry, task bar setting. I will be opening my taskbar setting. So I will be clicking on this, and now my taskbar mode is hidden. And if I go to object assignments, and here I have an option of local axis, I will apply local axis to frame assignments. You can see from here frame assignments, and will press OK. After pressing OK, now what you can see here is that local axis is applied here, but it has not been applied here. So I will again go to this and object assignments, local axis, apply to all windows, and OK. If you do not know what is local axis, then you can watch my previous video in which I have completely explained the use of local axis and how we used it. And this video is a practical use of local axis, that how we use and apply local axis in analysis of a structure. So now you can see that every structure has an individual axis. This is the global axis of the whole structure. Now each member has an individual axis, which is their local axis. And now if you see that this is our green color, so its name is local axis 2. So I will be applying load here directly. If you can see frame loads and distributed loads. Now I want to apply load at local axis 2 of this member, and distance is 0 to how much. You can I have not calculated the total distance, but you can calculate the total distance by using Pythagoras theorem, meaning 3 meter is horizontal and 3 and 2 meter is vertical, so it will be 5 meter. So I will be applying 0 here, and if we see UDL is 12 kilonewton per meter, so I will be writing 12 kilonewton and the distance will be 0 to 5 meter, and I will be applying UDL. Now you see that it's applied in the direction of local axis too. Since I want to apply it in opposite direction, so I will be putting a negative sign here. First of all, I will select this and then apply, and now you see it is in opposite direction and my UDL is applied in by the use of local axis. Now I will be applying my point load, and if you see that it is applied at a distance, what it is applied at a distance 0 to 4 meter vertical. So I will be going to etabs and will select this member, and it is applied at here, if you see. So I will go to assign, I will go to frame loads and point load. Now if you see that, what will be the direction of our load? Its direction will be what? Now we can apply with respect to local axis and with respect to global axis, but I will be applying here with respect to local axis. Local axis in this direction, we wanted the load in opposite direction, so I will be select it and will go to frame loads, point load, and will be applying my load at a distance, first of all absolute distance, and applying at a distance of 4 meter. And what will be the load? It will be minus 30 kilo, and its direction will be local axis too. And if you apply it, now you can see that our load has been applied. Okay, now what we will do now, since we are analyzing a general structure, so what we will do is that we will go to assign and we will go to assign and we'll go to frame and property modifiers, and here I will be making this self weight of the structure to 0 and applying, and okay. Now our loads has been applied. I have assigned the restraints. Now I will be checking my model as if there is any problem with it or not. So it is checking our model, and it will take a little bit time, and it will tell you that if you have made any mistake or not. So it's taking a little bit, but again in this video the main use was the use of local axis, and the concept of local axis is very important in etab. It will save very much of your time. If you do not understand local axis till now, you can check my previous video in the visit my YouTube channel, and in the my YouTube channel you can find a playlist of etabs in which I have make videos regarding etabs from start, and I will be moving toward the analysis of a complete story building. So stay tuned, and in there you will also find the video of local axis and global axis. So it generator said that model has been checked, no warning messages were generated. So now I will be running the analysis. First of all, we will be saving this file. I will just name it with 1, and I will save it directly, and now it has saved my model, and now it's started the analysis. It is taking a little bit, usually it takes 1 to half minutes, and now if you see that our analysis is completed. So our analysis is completed and it has shown all the messages regarding that we have made the solvent of the structure 0, so nothing important in this. So if I click on this, you can see this is a deformed shape of our structure in the 3D view. Now if I click on here, and if you want to find the reactions, you can just click on this and apply, and moment also there will be also a moment at point this point. So you can see that these are our reactions and this is our moment. And if you want to see the bending moment diagram for this frame, so I have just, so it is our bending moment diagrams, and if you want to know the values, this will be the values. And if you want to get the shear diagram, this is our shear diagram. And if you wanted to find the axial force diagram, so this is our axial force diagram. So this was the analysis of simple frame, but it contains very important concept, especially the use of local axis. So if you like the video, subscribe my channel and stay tuned to this, because in the near future I will be uploading very important videos which will be very helpful to you.